Hi, I'm Andy, and this is my lesson on the math class in Java. In this lesson, I'll show you how to use some of the static methods in Java's math class. I'll also show you how to make a class containing all static methods. Let's get started. Let's make a new class called Calculator. We'll make this class public so other classes can access it. This class is different than most Java classes. It has no instance variables because there's no difference between one calculator object and another. In other words, in this program, calculators are stateless. Since all calculator objects would have the exact same behavior, we're not even going to make any calculator objects. Instead, we'll just fill this class with static methods, and we'll access those methods through the class itself. Since we don't want any calculator objects made, we don't want this class to have a constructor that can be called by outside code. Remember, if you don't add a constructor to a class, the Java compiler adds one for you. To prevent that from happening, we'll add a constructor to this class, but we'll make it private. This seems kind of weird to do, but it gets the job done. Since we have a constructor, the Java compiler won't add one automatically. And because that constructor is private, no outside code can actually call it and make a calculator object. Now let's add some methods. We'll start with a method that calculates the volume of a sphere for us, given the sphere's radius. It's kind of random that we're adding that particular function to our calculator first. We're doing so because that volume calculation will illustrate several important concepts I want you to learn in this lesson. We'll make that method public, and we'll make it static, so it's accessed through the class, not a specific object. And we'll give it a return type of double. We'll also give it one parameter called radius. The formula for the volume of a sphere is shown here. Let's start writing the code that performs this calculation. First, we need to divide 4 and 3. However, remember how Java does integer division. If we put two integers like this, Java will truncate the result to an integer. In other words, according to Java, 4 divided by 3 is 1. Obviously, that would make our whole calculation inaccurate. To fix it, remember that as long as at least one number is a double, division results in a double. So we'll just change 4 to 4.0. Now we need to multiply by pi. We could put a decimal approximation like 3.14, but let's be as accurate as we can here. The most accurate value for pi that we can use is stored as a static constant in a class called math. As its name implies, that class is really helpful for doing math operations in Java, so let's look at it in some detail. Like the string class and many others, the math class was written by the Java creators and can be easily incorporated into any Java program you write. The math class is similar to our calculator class. It contains only static constants, called fields here, and static methods. For example, here's pi. Since it's static, we'll access it not through a math object, but through the math class. Let's go ahead and do that. Now we need to multiply by the radius cubed. Let's use a method from the math class to help us do that. This POW method does that for us. Notice that to use this method, we need to pass two doubles, the base and the exponent. So let's use the POW method. Again, it's static, so we access it by putting the name of the class ahead of the method name. Then we pass the radius as the first actual parameter and 3 as the second. This method requires 2 doubles to be passed, so this 3 will be automatically converted to 3.0 when the method is called. This code calculates the sphere's volume. We can either store its value in a double variable and then return the value of that double variable, but it makes more sense to just return this value directly. Let's go ahead and test this code over in our main method. First, let me show you what happens when we try to create a calculator object. This error here is reminding us that since we made our constructor private, we can't create a calculator object with new. So we'll get rid of that code and invoke our static method on the class itself, not on an instance of that class. Good, so that worked. Okay, let's go back to the calculator class and add a few more static methods. The next method we need to add is a simple one called distance. The point of this method is to calculate the distance between 2 points on a number line. For example, the distance between these points is 6. This method will have a return type of double and will need to be passed 2 doubles, x1, the position of the first number, and x2, the position of the second number. To calculate the distance between 2 points on a number line, we simply subtract the 2 positions, like this. The only problem is that if x2 is greater than x1, this calculation will turn out to be negative, and distance is always a positive quantity. To fix this, we simply need to return the absolute value of this calculation. The math method that does this for us is called ABS. Let's add one more method to our calculator class. I want this method to also calculate distance, but I want this one to calculate the distance between 2 points on a 2D coordinate plane, like this. The formula for this calculation is shown here. Since this method also calculates distance, albeit for different types of inputs, I want its name to also be distance. That means we're going to overload our distance method by adding another version of it to our class. This distance method will have 4 parameters. The first point's x and y coordinates, and the second point's x and y coordinates. As you can see from the distance formula, we need to do a square root. Let's look at the math method that does that. So this looks pretty easy to use. The method name is sqrt, and it has one parameter, the number we wanted to square root. Instead of putting the entire distance formula in one big messy calculation, let's calculate each piece of the formula a little bit at a time. We'll first make a variable called term1 for the first part of the square root expression. Then we'll make a variable called term2. Then we just need to return the square root of term1 plus term2. Let's give these methods a quick test before we go. Good. So that wraps up this lesson on some math methods in Java. I'm Andy. Thanks for watching and coding with me today.